talk about our journey to find bugs in JavaScript web apps in the wild at ICFP. So this is a joint work with my awesome team, Programming Language Research Group at KAIST, and our colleagues in industry, Score, Samsung Electronics, IBM Research, and Hong Kong University of Science and Technology. It was a PLDI this year. I was with my friends. I gave tutorial with some object-oriented people, and I told them, like, I'm going to give an invited talk about JavaScript at ICFP. And they were like, really? That's an honor, but are you going to be okay there? They may hate you because they hate JavaScript. And I was like, you know, they are nice and originally from the functional language community. And it's just like the moment when we, people working on analysis of real world apps, talking about soundness, someone makes a serious look at us and, oh, are you talking about sound analysis? I don't want to listen anymore. And I don't understand how come a logician like Peter is working at a company with that stupid slogans like move fast and break things. Done is better than perfect. I don't get it. And actually, this conversation actually happened at PLDI this year, minus some of my exaggeration. Right? So, yeah, today I'm here to talk about JavaScript at ICFP. I don't like JavaScript, but I'm going to tell you a little bit about JavaScript because it's really extremely functional, you know, and it's kind of object-oriented, but without any static types. We're going to talk about that later, and what we mean by web apps in the wild. So during the talk, I'm going to interchange in the wild and real-world web apps, and I'm going to tell you what we mean by that. And, you know, program analysis researchers have been working hard to analyze big code, large applications. But that large may mean different things for academia and industry. And those cool people, they have been working on sound static analysis. Sound means that we don't want to miss any execution flow. Any bugs reported by the bugs, they should include all the possible bugs. That's cool if that works, right? And it's really difficult to make that work in real world. So I'm going to tell you about these bits in order, and then talk about our journey to achieve this difficult goal. Before diving into the technical details, I'm going to give you a brief background of mine in terms of programming languages. So this is me, a college student, happily playing with this language called C. I didn't have much programming experience before that, so C was my first language, and I was fascinated by pointers. Isn't it cool? It's really crisp to say that X is a function returning a pointer to an array of pointers to functions returning character in this way. So I was weirder, right? My friends really hated it, but I was fascinated. That was the language for me for 4 years in my undergraduate study. And then my ex-advisor, Kwang, came to KAIST. And he introduced this functional language called Standard ML. I was like, what is that? And that book is pretty and yellow, right? Small. And I looked at it. Wow, reading one page takes forever. But I was really happy to see that you can explain a language, its behavior and semantics, not in prose, but in mathematics. I love Greek letters. They are so pretty, right? So I was sold by Standard ML, and this was my PhD thesis, detecting an uncaught exception in languages with exceptions, including ML and Java. And my first job as a master's student was to hack Standard ML New Jersey compiler written by Andrew Apple. And Matthias Blum, sitting somewhere here, he was like, ooh, it's really impressive. Could you read the code and hack it? Well, I really liked it. So see, I'm from the functional language community. And you know, that work is still available from this SML programming resources page. I was happy to see that. And our love for Standard ML moved to Objective Camel because it's not standardized, but they share the same beauty. So far, so good. I was happy. I was a happy graduate student, and then when I was about to graduate, I got two cool options. One, a postdoc at Harvard with Norman Ramsey, and the other with Radio Cuzo in France. So I got awesome options, and the thing is that if I back then chose to work in France, I may still remain in the functional language community. But mainly because of the two-body problem, I decided to go to Harvard, working on this new word, debugging. And the project that we worked on was the Debugging Everywhere project. Everywhere meaning that we'd like to have a debugging for multiple programming languages and multiple platforms. So we need to support very different programming languages like C, ML, Java, and multiple platforms like MIPS, Sparks, and x86. To support them, I had to learn how to walk through the call stack frames. Let's see, on the bottom, we have main function defined in mini-nub.c. On top of that, we have main method defined in fib.java. On top of that, fib method in the Java code, and the top level, there's another C. So in order to walk the stack frame, we need to understand assembly language. And I spent 3 years working on that. I really like Norman Ramsey, and he is a great teacher, as Derek said at PLMW this Sunday. He's a really awesome teacher to teach how to write papers and all that. But 3 years was enough for me with these low-level languages. As Max said yesterday, that disgusting low-level language, I had to escape to Sun Microsystems. And Guy's still here. He was our PI, and Guy was working on this cool DARPA project about helping people out there, scientists and engineers. Especially that project was a really big one, high productivity computing system project. And we are a very, very small part in that, working on designing a cool new language for the next generation called Fortress. So half of them are our graduate students, interns, and half of them were our cool members. Like Guy still, he knows almost everything about programming language, I think. He knows Java, Scheme, Lisp, and everything. And he joked like, in my desk drawer, I have 20 languages. So I was really impressed by him, and he's the most gentle, nice, and brilliant person that I've ever met. And Eric Allen, he was an expert in Scala and Java. David Chase, he once ran a company writing a Java compiler. And Jan Wilhelmsen here, he's a Haskell guru. Just awesome team. I learned a lot, enjoyed a lot. And the language design was really interesting. That was for the next generation. We had really cool ideas for 5 years, and the project died. But we made cool ideas. The final paper, I think, Guy still thinks that we can write more papers, and it's kind of slow. But I think the most recent paper is about this type that's published at TOPLAS this year. So if you're interested, please take a look at that. But I think the Fortress was really awesome. And while working on that, we were really adventurous in many ways. In the language syntax, we wanted to support mathematical syntax. For parallelism, we had parallelism by default and everything. And the type system is about to be crazy. So two of our awesome interns, Justin and Nels, they were working on writing a type checker for Fortress for 3 months in Java and failed. But they were so nice. We really liked them, and they were really good. So we hired them again in a year, and this time they wrote that in Scala, and they finished it in 1 month. And that completed version was the code size was 1/3 of the incomplete version in Java. So yeah, Scala was cool. Now Scala is my love these days. And I was happily working on the project for 5 years and came back to KAIST. And now we are working on JavaScript. So I told you that I've experienced with many languages, low-level language like assembly and C, and high-level language like ML and maybe Java and Scala. And why on earth JavaScript? Right? Yeah, JavaScript. It was meant to be a simple scripting language. It was developed by one graduate student in 10 days back in 1995. But now it's the language for web. It's everywhere. That's the #1 language in GitHub, the GitHub repository. That's the #7 in terms of TOB index, or whatever that means. And it has this thick language specification. Wow. And the language, I can rant over that for hours, but we can skip that. So let me give you a small example. This tiny code is a small subset of the jQuery library excerpted from this X13 paper. jQuery is one of those libraries written in JavaScript. There are many JavaScript libraries. The main philosophy of JavaScript, I think, is freedom. You can do anything you want. You can write code in any ways. You can generate code at runtime, and anything is possible, I think. And there's no standardized library. But jQuery is the most widely used one. It has 96% of market share. So almost all existing work about JavaScript analysis needs to handle jQuery. And let's see how bad it is. Okay, the size is actually 9,000 lines of code. And the outermost, you can see that's the immediate function call, right? You can see this anonymous function, open, close, really functional, right? So you have this outermost anonymous function, and you apply it right away to get a namespace. Because JavaScript didn't have any module system until last year. So that's called module pattern. Almost every JavaScript library uses this pattern. And this is the actual jQuery function. And it's a local function, but at the end, it's going to expose it to the user by assigning the function to this global variable in the .jQuery. Okay, and the actual jQuery object is created by this built-in function called object.create, which takes one object that's gonna be a prototype of this new object. Again, JavaScript is kind of object-oriented without any static types, so you cannot declare extension relationship at compile time. So at runtime, you can say that this is my prototype, kind of my superclass, and I can inherit all those properties from that. That's simple. So this object.create, it's gonna create a simple object and saying that, hey, your father or mother, your parent is gonna be this jQuery, that's fn. In the beginning, jQuery.fn has only one property, only one member. It's called extend, whose value is a function. It's a function taking some object, going through every property in the object and copies the value to this jQuery.fn. Now, starting from this simple object, we are building a jQuery object at runtime, right? And then later, that extend function is used like this, passing this each function. It's being used to add more functionality to this jQuery object. And this one takes a function argument and call that. So in this way, it's really extremely functional and dynamic. So that's just a small bit about JavaScript. As you can see, it does not have any static types. A variable may have a value of any of 6 kinds of types: null, undefined, numbers, boolean, string, and object. So you can get any type during runtime. Another thing is that functions are being used a lot, and property names are like this, meaning that they are going to be dynamically created. You can add properties or delete properties at runtime. Okay, so are you ready to hear more? Okay, let's go. Then why JavaScript? Right? I'm pretty well experienced and trained. Why JavaScript? Because that's everywhere. If you have any browser on your laptop, desktop, or any wearable devices, you can run JavaScript. So Java has this nice slogan, say, write once, run everywhere. JavaScript is more freestyle, right? You can run it anywhere if you have a browser. You can have any cool platform that has a browser, then you can run any JavaScript code. This is the TV in our lab. My students were cleaning up the room and they rebooted the TV and, ooh, can you see that? There are many undefined. Actually, that's the date. Undefined month, undefined date. What does that mean? Okay, it does not blow up the TV, but it's weird, right? That's JavaScript. Okay, so when I came back to KAIST, I was like, oh, what I'm gonna work on. So I really like Fortress, but I'd like to start a new thingy. What is it gonna be? And my students like, oh, there's a language called JavaScript. That's cool. And I didn't know anything about it. I was like, really? Okay, let's play with that. And soon I realized that, oh, I went to a weird world. And my friends were like, it's good that someone is working on that, but why you? And in the beginning, we were talking with these people from Samsung Electronics because there are JavaScript benchmarks from those browser companies, but those benchmarks are for performance, not about the correctness or anything. So we wanted to have real code to make real impacts. We wanted to save the world from JavaScript. So we talked to people in the industry. In Korea, Samsung is one of the biggest one. And they were like, it's good because we know how to analyze C. We know a little bit about Java, but not really about JavaScript. And we don't have many JavaScript developers in Samsung yet back then, like 5 years ago. But we do have lots of JavaScript code developed by third parties. We'd like to understand that. We'd like to measure their quality and things like that. So we started working together. That's the thing. Then, what do we mean by web applications in the wild? That should at least include JavaScript to have user interaction. But just simple JavaScript benchmarks there are not that many. They're only for performance testing for browsers, right? Then usually JavaScript is embedded in HTML documents like google.com, ebay.com, wikipedia.org. They all have HTML documents embedding JavaScript code. So HTML shows you the structure of the website, and CSS may give you pretty nice visual setting, and actual action is going to be done by JavaScript, and JavaScript should communicate with HTML DOM model. Until web pages. And Samsung has been waiting and waiting. When are you going to analyze our applications that use device-specific features written in native code, like in C, C++, or Android Java? So we had to handle that. Moreover, there are many dynamic beasts. And they also work with other programming languages. So these pictures show you our journey, and this talk is not that technical. If you are interested in these technical details, read the paper, please. And you can come back to me after the lecture today. So today, I'm going to tell you a story from a person who used to live happily in this beautiful functional language community and now fight against this dirty real-world problems. And you can feel pity on me, but I'm really enjoying this work, and I'm going to tell you about it. So what do we mean by real-world applications? Every organization may have a different criteria for that. And in terms of the code size, most of the publication about JavaScript static analysis, the main beast is, again, the jQuery library. And it's 9,000 lines of code. So using that, it's just less than 10,000. We are working with Samsung people. There are some sample web applications that you can look at too, but many of them are secret. market applications. Main reason is that that's not developed by Samsung, so they cannot show that to us. So even though we have this work together project, we need to get into the headquarters to see the actual code. Only some of them. All the others, like this network configuration apps, like 50,000 lines of JavaScript code, we cannot even see it. We cannot even run it. They're going to do that for us and give the result back to us. It's like, oh, remote understanding of the beast. And then Oracle Web Apps. Now, we are recently working together with Oracle Labs in Australia, developing a static analyzer for large code. And they said they have millions of lines of web apps, including C and C++. Among them, 700K may be JavaScript. In Facebook, there is a publication or newspaper saying that Facebook has millions of lines of JavaScript code. So it is not that surprising that IT companies want to have their own tools to analyze them. So Samsung has Sybase, and JSA is a JavaScript analyzer that contains some variant of our tool Safe and Jalangi. And our tool is now officially integrated in this Tizen platform. Oracle has Parfait and Souffle, and Christina Cifuentes is giving talks in many places telling what she had to go through from delivering these cool research achievements to the product team inside Oracle. So she has been giving the talks here and there. And then Peter gave a talk. He is giving talks in many places these days. And this year he gave a talk at Korean to talk about move fast to fix more things. Slightly twisted, but better slogan, I think. And they are so passionate. So when I mentioned them, I'm going to give an invited talk at ICFP. And they sent me an email writing what they want to deliver. So Krishna was like, in-house tools is really cool because there are other tools like commercial analyzers, but it's not really focused on your code. So Christina's team, I knew her from Sun Labs. She was at Sun Labs. Parfait was the first tool that could analyze the millions lines of C++ code for Solaris operating system in 4 hours. So that was really scalable. When Sun sadly was gone and Oracle purchased Sun Labs, Oracle was like, what is a lab, research lab? Let's see what it is. And they spent a year and they cut the size like 1/3 in a year, but they kept this analysis team. So in the beginning, they were like, let's see what you can do. Please analyze our Oracle DBMS source code. And they found many bugs. And they were like, ooh, this tool is cool. How about Java SDK source code? It's a different beast, and now she's really busy working on analyzing Java code. And at the same time, she's also interested in analyzing JavaScript code. That made us to work together. And Peter, this Sunday, I think, I sent an email to him, what's the number of the lines of code for Facebook web apps? And he was like, I cannot tell you, I don't know the number, but even though I know, I cannot tell you, but there is a publication about millions of lines of code. He gave me all those numbers. And then, you know what? Analyzing big code is really important. You need to say that to the people. So hopefully, I'm delivering the message enough here. Okay, and the final bit is that, before telling you about our journey or struggle, are we really interested in static analysis that is sound for real-world applications? Maybe not. Maybe not. I mean, I really admire all the cool work that I've heard yesterday and today, I think, and tomorrow, right? All those sound work, really well formalized work using lambda calculus and some extension of that, really. And that actually helped us to move forward. But there's another area that demands on precision and soundness may vary between clients. If we are talking about verification and validation, we want that confidence. But for bug finding, we may miss some bugs. We may not find bugs here, but at least we'd like to get some. usually it does not terminate because it's too difficult. So what we are trying to do is, this is a quote from the Soundness paper. Soundness is not even necessary for most modern analysis applications. However, as many clients can tolerate unsoundness. And I can understand if you don't like it, because I did not like it in the beginning. Still, how can I say that? I do not like it, but I think I need to live with that if I'm going to stay in this problem. Okay, now finally, let's talk about our journey. In the beginning, I was from Fortress, you know. That's the most crazy language I've ever seen. JavaScript, what's going to be difficult? So I started, and this is the usual language manipulation pipeline. You get the source code, get a parser, write a parser, and then get an AST, build an intermediate representation, build a control flow graph, and analyze it based on the cool abstract interpretation-based static analysis. So far, so good, right? So even though a variable in JavaScript may have any value of any type during the runtime, we can have a tuple of all those 6 kinds of types. Just typical work. So we did that, and we formalized the language specification, semantics, and made the tool publicly available. And then, back then, there was no module system, so we wanted to support module system. Any reasonable language should have a namespace. So we added a module system, extended the syntax to have that, and desugared that away at pre-processing time. And prove sound that this module system enjoys these cool properties. And then with statement. So JavaScript is mostly statically scoped except one language construct called with statement. So there is a different story about it, but anyway, we had a systematic way we developed that and implemented that so that if we get a JavaScript code, a program that uses with statement, get rid of that. So this tool is really lightweight, and it's being used by JSI from UCSB and KJS, this JavaScript semantics in the K framework from UIUC. They are using our tool happily. But while we are working on that, JavaScript, we started working on this topic to save the world, to help the developers, but they didn't like us. They were like, yeah, right, you are writing papers, that's good, but what you are considering is not JavaScript. That's a toy subset of that we don't use, and you are working on that because that's easy. So we were like, oh, really? Are we doing that? So we collaborated with this empirical study, this software engineering people from Hong Kong University of Science and Technology, and we studied empirically how JavaScript web apps are being used and how do they behave. And we found that JavaScript standalone projects, not like web apps, JavaScript standalone projects are just like Java projects. And JavaScript web apps are just different beasts. So we need to understand that better to solve real problem. So we extended SAFE to interact with HTML documents so that then we can analyze eBay.com page and Wikipedia.org page. So in order to do that, we had to model that DOM object, meaning that how that HTML document is structured. And there were 2 cool versions already, one from Microsoft called Gatekeeper, another from Aarhus University led by Anders Miller called TICE. And they're really cool. And they were capturing this document object model, which is HTML document, intentionally imprecisely, because they were concerned about scalability. And our approach is to take the other way. We wanted to capture that precisely, because in this JavaScript world, things are different. So back when I was a graduate student, I heard CF control flow analysis from Olin Shivers. That's really awesome. And there's KCFA, zero CFA. It's good but not really precise. 1 CFA, that's better but expensive. 2 CFA and more, they are way more expensive but not that much difference. That was my knowledge from the book or papers. And we apply that to JavaScript and not really. Actually, in many cases, more precision gave better scalability. So we used more precise modeling, and that worked really well compared to the other model. So it was interesting. Another thing is that now that we can analyze slightly bigger code, we need to analyze jQuery. And as I showed you before, it's really loop-intensive code. It's going to add many stuff at runtime using for-in loops. So we had special technique for loop-sensitive analysis. Again, the details are in the paper. And Samsung has been waiting, right? So, okay, can you analyze our code now? Okay, let's see. So in this work, I'm going to show you a little bit more about it. Samsung has a set of API functions to help JavaScript developers so that they can use some device-specific features like your geographic location, your contact number, phone number, things like that. So they publicize the set in the form of web APIs written in a language called WebIDL, Web Interface Description Language. Yeah, it looks reasonable, right? There is a name for the function, parameter types and return type, sometimes whether it throws an exception or not. So the JavaScript developers are going to use them, and this JavaScript code is now called a native function and get the result back. And they can even pass JavaScript function to the native code. See, here success callback and error callback, meaning that those are JavaScript functions passed to the native code written in C++. And that API function may do their work. And then if it succeeds, call the success callback function from JavaScript. If there's a failure, then it's going to call this error callback function. Again, JavaScript code. So they need to understand all those things. So that's all written in API specification, and it's not that easy for ordinary JavaScript developers to follow the track. Let's see, here's an example. Here's a simple JavaScript code that uses this getCalendars API function. Then that developer needs to understand, oh yeah, this getCalendars function that's defined here. And it has 2 arguments or 3. The third one is optional. I have 2. So far, so good. What's the first parameter? Calendar type. What is it? Is the string event, does it have the type? Then the person needs to go to the definition of the type. It happened to be an enumeration of strings. Okay, what's next? Like that. That poor JavaScript developers need to navigate the API specification here and there, everywhere, until finding an error, right? So the developers were having a hard time doing that, especially JavaScript developers, because they love freedom. In the ECMAScript specification, it's valid. If you have a function declaration with 2 parameters, in the call site, you can of course give 2 arguments, but it's perfectly fine to give 3 arguments or 4 or 0. If you don't give any arguments, then they're going to be, by default, undefined value. That's the default value. So for the JavaScript developers, it's perfectly fine to give any number of arguments. Why? It's an error. I don't like it, like that. So we developed this tool. We actually automatically model the behavior from this nice API specification. And as Peter would say, the rate of false positive and false negative may be meaningful for paper writing, but maybe not that for actual developers, because they don't know. They don't know whether that's true or not. So it has really impressively high fix rate. For example, when we gave 88 reports to them, they fixed 80 out of that. It's like 91 fix rate. And the thing is that it's not like they are not smart. They are really smart. The thing is, there are so many open source code. There may be some issue in jQuery or other libraries like MooTools and any other things like that, and they don't know how to tackle that. So if it's a simple way to fix that, just fix it away. So that's what we got from them, and now it's integrated in Tizen SDK. And now we are enlarging the analysis scope here and there. And now it's a lot of control flow graph. There are so many execution flows. And web apps are usually driven by user interaction. User click this button or that button, then it's going to fire a JavaScript function. So anything is possible. The control flow should be really conservative. Then, wow, it's going to be black with lots of edges between the event functions. So how can you analyze that? And now it became our collaboration with Julian Dobie from IBM Research working on Walla. So Walla, I think some of you know, that is a successful tool. It has been really successful in analyzing Java programs. And now it's also being used for analyzing JavaScript. In the beginning, they were like, Walla is so cool. It's going to be language agnostic. They had one intermediate representation for Java. Why not for JavaScript? Oh, yeah, not for JavaScript. They had to fork it and add this and that. And okay, we changed the IR, but how about analysis techniques? They know how to analyze large Java code. So they tried various techniques to analyze JavaScript in a sound way. There's a paper called Correlation Tracking and Dynamic Determinacy, cool papers out there. But recently, they decided to go unsound. And that's the paper that I cited before, XC13 paper, using unsound call graph construction. That's my way of saying that, and they would say that approximate call graphs. So, okay, then if you are gonna give us a version of call graph, then we can analyze that. So this work was a collaboration using the call graph emitted by Walla, meaning that there is a lot of execution flows, and Walla will give us a subset of that, and for that subset, we can analyze it in a sound way. So that was our work last year. And another beast is dynamic. A lot of dynamic code. There are dynamic code generation by the evil eval function, and there are loaded files at runtime, and many possibilities. So we looked at the code because they gave us the code, and when our tool analyzed it, the analysis coverage is not that good. In a given web app package, there were 400 something JavaScript files, but Safe could analyze less than 10 files. What happened? There were 300, there were 700, but not at all. So we analyzed them. One main reason is that those files were loaded at runtime. Then, because you're smart, one obvious solution would be just include them all, analyze them all, 700 files. That doesn't make any sense. Even Walla cannot build a call graph for that. So we looked at it and realized that out of 400 something files, 409 files were test files. Why on earth they include that in a web app? Who cares, right? So we didn't have to analyze them. Another cool example, the 350 something files, they were international locale setting, one for each country. So at runtime, only one of them is being loaded. So all those domain-specific knowledge helped us to eliminate some false positives in the real-world applications. Okay, time to boast, right? Okay, so using the Safe, we could find some errors in JavaScript code, and this is my favorite. We analyzed Wikipedia.org because that was the #7 web page that has many visitors. So we analyzed them, and there is this language selection button. If you click it, the default language is English, and you can change it. If you click the button, this code is going to be evaluated. You don't need to read the code. There is this equality, triple equality. And everyone thinks strict equality is better. Everyone, including JS Hint and JS Lint, they're simple-minded tools. The problem is that if we use the strict equivalence operator, if two arguments have different types, it's going to be always false. And hey, the default language defined by this function call, that returns either null or object. And the language you chose has a string type. So this code always evaluates to false. So we were happy, sent an email, and the Wikimedia team was like, they got back to us right away. And they were like, ooh, Wikimedia team wrote not only Wikipedia, but 9 more pages, I think. They had all the same bug. So they fixed it. We were happy and wrote a paper. 1 year later, we had another cool technique. We collected those top 10 websites and analyzed them, and the bug came back. Isn't it cool? And this is all publicly available, the discussion. We sent an email with this history, and someone looked at it, and there was one software engineer at the Wikimedia team. That person changed some irrelevant code, and because the engineer is a good one, disciplined person, he ran JS Hint. And JS Hint said, oh, you are using this double equality? No, use strict equivalence. So he do that, and that's become like, there's a bug again, die hard, right? So we had this discussion, and they were like, okay, how can we revise this code? They just entirely rewrote that code. So that was my favorite. And then we found more errors from Tizen sample apps that use this inter-operation between the native code and JavaScript, including this cute game, right? We found some errors there. So we were happy until then, right? And now the tool is almost everything is open source except Samsung specific parts. And now we are revamping this tool. We are planning to release Safe 2.0 at the end of September. Stay tuned and please use that for us. Okay, so that's the main part of it. And the most recent work that we are working on is analyzing hybrid web applications. Yeah, not only JavaScript, how about Android? That's cool, right? There are so many platforms out there. iOS, Android, Windows, BlackBerry, that's there because one of my students is still using that, and Tizen, right? And they have very different native code. iOS used to use Objective-C, and now Swift. Android uses Android Java, and the other languages like C++. So in order to support that, actually recent studies said that people have multiple platforms. Yeah, I do have some Tizen watch that's really big that doesn't go with my arm. I mean, and a laptop and desktop, they use many platforms, right? So in order to write cool applications, the traditional approach is to write native apps for each platform. You need to write that in Objective-C and Android Java and C++. Oh, that's too much. And another approach is to have web apps. If you can run it on a browser, then it's going to be everywhere. Except that web apps cannot access device-specific features. There's this pros and cons. So hybrid apps may be a solution. It's going to be fully accessible to these device-specific features, and it's going to be really, partially, but really, portable. So hybrid apps, meaning that it's going to use all those HTML5 technique to do all those web-specific thingy to support platform-independent features, and then a set of ways to use device-specific features, right? So we are working on that. Because every other thing is closed, we are working on Android. The problem with Android hybrid applications. It's actually better than JNI. Java and native C code, no, been there, done that, not for me, right? And this one is better because we have source code for JavaScript and Java. Yeah, not really source code for Java, but we have bytecode. It's close. The thing is that there's no one single document for describing this interaction between Android Java and JavaScript. Java is strictly typed, well-disciplined. JavaScript, what is a discipline, right? And Java, there's a type system. JavaScript, not really. Java, it has overloaded methods. JavaScript, not really. It's kind of overloaded, right? When you have a function declaration, you can use it anyways. But they are different. Another thing, web applications are really vulnerable to security attacks. Cool or interesting thing is that advertisement platforms, they are really vulnerable. We are also still writing a paper about it. There are holes here and there, everywhere. So this is one document about how to interact with Android Java and JavaScript, just one homepage, one page. If you look closely, it says that use of this method in a web view containing untrusted content could allow an attacker to manipulate the host application. Use extreme care. That's it. Really, if it requires an extreme care, why don't you have a tool to detect that and let the developers know that? So that made us to work on these hybrid applications. So here's a simple code telling you how they work. So here's Java code. It has a class called bridge. It has one method named send. And here's add JavaScript interface. That's the magic keyword saying that my Java object, new bridge, is going to be passed to the JavaScript environment. Hey, JavaScript, you can use my object because I allow you, but using this name bridge. That's all it says. Then JavaScript can call the method on it. That's how they interact. Again, this method is going to let that know that you can use this name to call this. We call that bridge object. And then using that, it can call this Java method. That's simple. So that one page describes that, only that. What about different types? If I pass a string value here, is it going to be the same string? If it expects a string, if I pass a number, what happens? It has a method overloaded, and I did not satisfy the requirement. What's going to happen? Doesn't say anything. I think there are so many cool Android application developers who are really smart. How can they know? So we worked on, I told you about all those work about JavaScript analysis. There's our safe on the top, and Thijs from Anders Miller, Jaysai from UCSB, Walla from IBM. There are really many analyzers for Android. I couldn't even enumerate them here, but not really about their interaction. So that led us to work on Hybridroid. This work is presented at ASE 2 weeks ago. And it's a Soundness analysis framework. Because no existing Android analyzers or JavaScript analyzers are sound yet. Then how about the interaction? When they have cool analysis tools, we are going to steal that. But until then, we are going to focus on this interaction. About JavaScript analysis, there are many good work. About Android, there are many more work. And for the interaction, we are focusing on that. So we have this Hybridroid. It's now officially a part of the Walla. We are using Walla instead of Safe for this because that has a built-in support for Android Java analysis. But we can apply the same idea to Safe and other tools. And there are two client applications of that, bug detection and taint analyzer. So the same example before, slightly different, because now send method expects two parameters, string and integer. And JavaScript cheerfully send one string argument. Then Hybridroid will let the developer, hey, this method in Java that has a type system, you know, it expects 2 arguments, you'd better give 1 more argument. There are several errors that we can detect, something like that. Another thing is going to be, oh yeah, here JavaScript passed a string value, but Java method expects a Boolean. What do you think is going to happen? An exception or a default value? In the Java language specification, actually, there is a default value for every type. So if it expects a Boolean, it got something else, okay, it's going to be false. Right? So our paper talks about that in detail. Another cool thing is about taint analysis. Taint analysis is a cool application of an analysis because it's the analysis scope is smaller. We have a source, we have a sink, and we want to analyze the flow. There are many cool work about taint analysis in Android and taint analysis for JavaScript, but not for interaction between them. But you know, sources can be anywhere, sinks can be anywhere. So in this example, this JavaScript code calls the Java method and then asks for the phone number. And this Java code is so nice to give it away. And then this JavaScript code throws it out to the network. So the source is now in the Java code and sink is in JavaScript, and our hybrid droid can catch that. That's it. So in the beginning, I was only thinking about this API mismatch. They have 2 different type systems. I know type system. There are going to be errors. Not that many, because JavaScript, I mean, the Android hybrid developers are kind of timid in the way of using that. But we found unexpected errors. That's cool, obfuscation. So in this Java code, they have this receive method, and JavaScript calls the method. And because web apps are often obfuscated to secure their code, they rename the names. So in the after obfuscation, this receive method in Java may be renamed as ABC or P or R. And the JavaScript code does not change because the names were in string before. So we found many real errors that we can make the application go wrong. So that was cool. Okay, now it's time to wrap up. So again, these codes are from Peter's talk at Korean this year. And he, as I said before, he sent me an email about what he wants to say more. So Peter said, applying academic research in industry, it's an adventure. It's a journey. The term journey, I stole from Peter, from his invited talk at Aplas last year. And he said, we need to apply it to big code. Really, millions of lines of JavaScript code. And more important thing is not only big code, but a huge momentum. In Facebook, their code size is big. At the same time, they're changing a lot. In a day, they have 1,000 commits. So even a linear time complexity of whole program analysis is slow for them. So what he's been selling these days is compositional analysis, and I'm going to talk about that in a minute. So here's a request to the functional language community saying that help us. Help us with your cool research achievements. So I'm going to name just 2 that I have been thinking a lot these days. So scalable, precise control flow analysis. After all, we'd like to understand control flows. For C, yeah, they have function pointers. For Java, yeah, they have reflection, but they are not really used a lot. ML, Scheme, I really like them, and I use Scheme for my undergraduate programming language course every semester, but they even do not use interprocedural analysis in the Scheme compiler, as Sam told me. So they are really cool work, and I was fascinated by this line of research, CFA2, that has this time complexity for monovariant control flow analysis. And then push down control flow analysis, much better now. Abstracting, abstract control, N to the 8. And now, this year, there is this push down control flow analysis for free. I got it. And that was N cube for a monovariant analysis. And yesterday I talked with the authors and I got an open source implementation of that. So excited, but not yet sure whether we can use it for this really big code analysis. But I'm hopeful and I'd like to steal any good ideas from them. Another topic is compositionality. Peter has been talking recently, like whole program analysis is gonna never work for this size of code. We need compositionality. It's not really new, right? There have been like compositional analysis, incremental analysis, separate compilation, even back when I was a graduate student. And there are cool papers these days, you know, compositional shape analysis, that's the secret behind infer, and hybrid top-down and bottom-up interprocedural analysis, and really awesome work by Isildilic, and there are many cool work that's pushing the edge of the analysis work. So I'm studying them and keeping eyes on them until we can steal it and use it in actual analysis of real-world web applications. So our journey has not yet finished. We are extending the analysis scope from simple, small JavaScript to HTML documents to browser-specific functions to dynamic features to multiple languages and what else? Events. And there are many asynchronous features and more adventurous features that I didn't have time to name. So we are on this journey and we are gonna be happy and shameless to steal any great ideas from the functional language community. Thank you.
Thank you very much, Sukir, for this great talk. We've got time to take one or two very quick questions.
Hi, Jeremy Gibbons from Oxford. Thank you for a wonderfully enthusiastic talk about JavaScript web applications in the Wild West. You're doing great things to help all these poor developers with these crazy languages and crazy techniques to stop themselves shooting themselves in the foot. I can't help feeling that you might be even more helpful if you persuade them not to shoot themselves in the foot in the first place.
Excellent question.
And I wonder if you have any thoughts about that. Is it inevitable that we're going to have to deal with these loose, crazy languages, or should we be pushing the community not to be doing these things?
Right. Really excellent question. I wanted to comment on that. So in the beginning, when I just studied and whenever I go to a conference, whenever I meet those people working on JavaScript analysis, I was asking, what are bugs in JavaScript? What are the things that they care? And like, let me get the names correctly. David Herman from Mozilla, Sam from, at the time, Northeastern, and many people working on JavaScript, they were like, we don't know. Actually, we are trying to apply these static analysis techniques to this crazy language, and we hope to help them, but don't know it yet. That was one answer. Another is that I have two daughters, and when my daughter was 7 or 9, she started writing JavaScript code. Code.org, right? All those pages. And there are so many JavaScript code, and who are our clients? Well, whom are we talking about? And actually, that work from this API misuse detection, that was that was a clicking moment for me, for us. Because, oh yeah, there are people, there are developers who care about specification, who care about the bugs, and they care because they want to sell their third-party applications to the big company called Samsung. Samsung cares because Samsung is the #1 company for smart TV, LG is the second over the world, and if their TV has some security vulnerabilities because of JavaScript, ooh, that's dangerous. right? So we are not helping any random JavaScript developer like undergraduate student or my daughter. No, I don't care. But for those real world developers who want to write robust code, we want to help them. So that's one answer. The other is that when back in Java 1.4, there were no type parameters in Java. 1.5 now has generics. At that time, Guy Steele from Soundness, and Martin Odersky, the father of Scala, he was at Sun back then, and they were debating about how to support type parameters in Java bytecode, because it doesn't have that back then. And Guy was like, we need to redefine Java bytecode to have real type parameterization. And Martin was like, then no one is going to use Java anymore because it's not going to be backward compatible. It's not good for the company. And you know who won, right? So now Java has type eraser semantics. It has type parameterization at compile time, but after compilation to Java bytecode, it goes away. So seeing that, I think it's really difficult to change people's mindset, but still there are good movement like Flow from Facebook, TypeScript from Microsoft, and those type system for JavaScript. And ECMAScript 6 now has better static semantics that are checked at runtime. Isn't it cool? Anyway, so the world is moving forward, maybe not that fast enough. ECMAScript 5 has been alive like 10 years, I think. You know what? ECMAScript 4 never existed. Because after ECMAScript 3, people like, ooh, the language is cool, we need to make it sane. So they had really nice proposal, and the JavaScript developers vetoed that. We are not going to take it because that's not JavaScript. So ECMAScript 5 was really conservative to make them work, adding strict mode to use better code, and limiting the use of eval and with construct in the strict mode like that. They are very cautious to convince people. So there have been movement like that, and yeah, we are working on that. Thank you. Thank you for the excellent question.
So let's take other questions offline. And thanks again for a great talk.
Thank you.
May has a very quick announcement about the Lambda Lady Lunch this noon.
Just really quickly.